Hello, and thanks for stopping by. Today we're going to be looking at Top Interview 150 Questions by Leetcode. This is a problem set that should be very good and should be very helpful for you to learn how to ace your interview questions going down the road in the future. So without further ado, let's get right into it. Once you get Leetcode opened up on your screen, you can go ahead and navigate to the problem section here at the top. And under Study Plan, you'll see a section called Top Interview 150 Questions. So once this opens up, there's this first section called Array String, and we're going to be looking at this first problem here called Merge Sorted Array. And this is an easy difficulty, so it should be a good one to get us started with. Once we have this open, we can go ahead and look at our code editor here to make sure that we have Python 3 selected. I have that selected, and now I'm actually going to close this out because I don't want to be distracted by this over here. Okay, so now that the code editor is closed and we don't have that to distract us, we're going to go ahead and get started at reading through the problem for the first time and kind of understanding what each element of this means. So we are given two integer arrays, nums1 and nums2. They're sorted in non-decreasing order. Non-decreasing order is just a fancy way to say that they're numerical order going from the smallest to the largest and that there could be duplicates. There are two integers, m and n, representing the number of elements in nums1 and nums2 respectively. We want to merge nums1 and nums2 into a single array, again sorted in non-decreasing order. So it should be the same order that it is in already. Now the final sorted array should not be returned by a function, but instead it should be stored inside of the array nums1. So that's important to remember because we're not going to be creating a new array or returning the values of the function. We're actually going to be saving nums1 and overriding the elements in it. So to accommodate this, nums1 has a length of m plus n. This is important because we have to remember that it has the correct number of elements already. The first m elements represent m, and the last n elements are set to 0, and those are for the n elements in nums2. So now that we have this understanding, we can go ahead and take a look at an example. So I have example 1 here. I actually put this into another window, so let me go ahead and switch over to that so we can try to visualize this a little bit easier. Okay, so the example here has nums1 and nums2. Nums1 has m equals 3 elements, nums2 has n equals 3 elements. So our output should have 6 elements total. And to get this output, we are going to want to sort it in non-decreasing order. So we have 1 is going to be our smallest element, then 2, there's a second 2, then a 3, then a 5, then a 6. So pretty straightforward. So the 2's here can actually be the second or the third element. That's important to remember because you might run into an issue with that. But let's go ahead and look at these arrays kind of built out in a visual to make it a little easier to follow. So to start off with, we have nums1, which has the 3 elements and then the 3 zeros, and nums2 with the 3 elements. The smallest element is the first element of nums1, which is at index 0. So in Python, indexes start at 0, so we're going to want to remember that nums1, we want the first element, which is index 0, so that's 1. Next up, we're going to look at nums2. So 2 is going to be the next smallest element, and we could pull that from nums2. We could also pull it from nums1, but we're actually just going to pull it from nums2 for now, and then nums1, the second element, we're going to set equal to the third value. So we'll go in the order of nums1, then nums2, then nums1, and then we'll go to the third element in nums1 again. That'll be the fourth, and then of course 5 and 6 are the last two elements. Now, if we're going to try to actually put this into the nums1 array, once we overwrite this, 1 is already in the right spot because the smallest element is in nums1. That first integer array, it's pretty easy to leave that in the same spot, but we'll just say, for instance, that we overwrote that 1 with the same 1. Now, we're going to overwrite the second element in nums1. So it's a 2. We're going to pull that 2 from the nums2 array. So now that's overwritten, and we have nums1 is this bottom row right here. This is what it currently looks like. So although up here it says 1, 2, 3, down here it also says 1, 2, 3, and it's overwritten with the second element from nums2. If we were to now try to pull this second element from nums1, we're going to actually be pulling a 2 because the 2 in nums2 overwrote this. So we won't notice an issue here whenever we overwrite that. But now, if we were to try to write this fourth element, which is supposed to be the 3, we wouldn't be able to do that because it's going to pull from nums1 this 2. So it's going to go 2, 2, and then it'll do 5, 6. So it'll mess it up because it doesn't know that this has already been overwritten. So to accomplish what we're trying to solve for, where the numbers are going from 1 to 6, small to large, we're actually going to go in reverse. We're going to go from large to small. So we're going to look at the farthest side, and we're going to start with this last element and work our way backwards. So the last element here is going to be the largest, which we see in the output. It should be a 6. So our 6 is going to be our largest element. So let's go ahead and put a 6 there. The next one will be the 5, and then the next one will be the 3, and we can just work our way down, right? So as we work our way down all the way to 1 being overwritten, even though we didn't have to, we now have our result that we wanted without overriding anything. So this is where we're going to want to be. And we can actually see that this is not going to override any elements because when we take the last one, we're overriding a 0. And then whenever we got to the 3, it would overwrite a 0 again. So it still shows a 3, and then it will be overwritten by the 2's. Okay, so now that we have this, let's go ahead and go back to our code editor. So we're going to open this up in Leetcode, and we're going to start looking at this. This first section here, it's just a commented it out section. It's using triple quotes, so you can write multi-lines of code. So you can write note, note, there's no issue. You can do the same thing with single quotes or the apostrophes, and you can put notes in there as well. But I'm going to get rid of all of this for now. You don't need any of this, but I will actually use hashtags to write my code out. I just find it's a little easier whenever I do it this way. So the first way that we're going to do this, we're going to do a sorted array. You can take nums1. So this is going to be our array that we're trying to overwrite. So this is what we're going to overwrite in the end. And we're going to set it equal to sorted. This is a function that's already built in, so we can just use the sorted function. And we're going to take the first elements of nums1. So we can use nums1 through m, and we're going to add all the elements of nums2. So this is essentially saying start at the beginning and go through m elements, which m is 3. We don't have to make any changes there because the index works how we want it to. And then whenever we return this, because I need to put nums through n plus m is equal to sorted nums1 m through plus nums n. Oops, I meant to press run, but I just submitted. So you can see that actually works right there. You don't have to make any additional edits or do anything different than this. It's very simple to just use the sorted function. This function itself is not the best, though, whenever it comes to the most optimal way to write this. So if you're working with a large data set, you might want to actually look for something that doesn't take up so much time or space complexity. The space complexity is not bad per se, but the time complexity could definitely be better. So currently space complexity, we're creating a new array and we're setting it equal to the elements of n plus m. So this is equal to the big O of n plus m space complexity. It's not a bad amount of space. It's just an additional array that has the same amount of elements as already listed out. But we're going to find a better way to do that. And then for the time complexity, to run through this, we have to go through every element in the list one time. So that's n plus m. And then we're going to sort it afterwards. So on top of that, we're actually going to do a log of n plus, log of n plus m as well. So we're going to say that this is our time complexity, where sort turns it into a log of n plus m. So to get a faster example, we're actually going to use pointers. So let me say pointers here. There's probably a different way to define this. I just think pointers makes the most sense to me. We're going to have a pointer for the first, a pointer for the second, and a pointer for the end. So let me show how this is going to work. So we're going to have a pointer pointing, we'll say M right here. It's this third one. We're going to have an in, which is this 6 right here. And then we're going to have an end, which is the last one of the new array. So I'm going to say, we'll call this pointer, we'll call it just pointer 1, pointer 2, and then end. We'll just use simple ones like that. So pointer 1, pointer 2, and then end. And then we're going to set this equal to, so pointer 1, let me go back to the description so we can see the problem here. So for our nums1 array, we have a value of m equals 3. So we want to set this equal to m, so there's 3 elements here. But if we found index of 1, 0, 1, 2, 3, it's not actually the right number that we want. So since Python uses 0 as the first index, we're going to say -1. If you're doing this in a different language, you could do it just the element. But we're going to do the same thing here for nums2, where n is -1, and then we're going to do m plus n -1 for the end of our final output. So it'll start in this last index right here. So nums1, just go for example, so p1 is equal to m -1, so 3 minus 1 is 2, so 0, 1, 2, that's correct. N -1 for p2, 3 minus 1 is 2, 0, 1, 2, that's correct. And then our end is 3 plus 3 minus 1, so that's 5. We got 0, 1, 2, 3, 4, and 5. So this is working correctly, how we have it right now. And you can print these out if you want just to help, but I see that it's working correctly. So I'm now going to work on deciding which element is the largest. So I want to say, I'll just put this here, which element is the largest so that it's easier to follow. We're going to say if nums1 p1 is greater than nums2 p2, then I want to say nums1, because we're going to overwrite the nums1 array, and we're going to say the last value is equal to nums1 p1. Let me see if this is correct. So if nums1 p1 is greater than nums2 p2, so if nums1 p1 is greater than nums2 p2, then take this one. Yep, so that's correct. And then if it does take that, we're going to want to make sure that P1 is subtracting out 1, and the same for the end. You can also say end equals end -1, but it's just a little neater to say minus equals 1. And now we want to do the else. So the else part is going to be if nums1 is not greater than nums2. So here, nums1 is not greater than nums2, so we want to take nums2. So we will say that nums1, the final element, is equal to nums2 p2. And now we want to subtract 1 from p2 and subtract 1 from the end. And you can see that we duplicate the same effort in both sides of the if-else statement. So we don't want to do that. We can actually remove this here and pop this out of the if statement. So now we have an if statement that says if nums1 is greater than p2, select nums1, otherwise select nums2 element, and then end -1 to go through all the elements in the list. So this is going to work. Let's go ahead and try it. I'm anticipating some edge cases will pop up that will make it not work actually. Oh, sorry about that. Let me comment out this part from the top and we'll run this again here. Okay, so I ran into an error here. If nums1 p1 is greater than nums2 p2, it says the list index is out of range. So I figured there would be an error here, and we're going to actually resolve this really fast. Um, the issue here is that we're going to keep subtracting elements, and we're eventually going to get to an element that's too low. nums1 p1 and nums2 p2 might go below the first index, which is not what we want to have happen, and that'll cause an issue for us. So we're going to need to create a while loop saying while p1 is greater than 0 and p2 is greater than 0. We want to work through all of these examples. Now, whenever I run this, we should no longer have that error. There we go. We don't have that error anymore. But the answer is not correct for some reason. We still need to fix this. So the issue that we're missing now is our final edge case, that whenever P2 ends up being having more elements than P1, we want to return the leftover elements for nums1 end is equal to nums2 p2, and then p2 minus equals 1 and end minus equals 1. Fix that. Oops, I did not mean to submit, but I just submitted. And we can see currently getting an output of 1, 2, 3, 2, 5, 6. Oh, it's because it has to be equal to as well. We don't want to skip this if we don't want to skip this list if P1 or P2 are equal to 0, because it goes while P1 and P2 are greater than 0. We can see we start with 6, and then we go to 5, and then 2 is going to be a 0 index. And whenever we have a 0 index here, this is 0. When it wasn't equal to 0 as well, it'll give us just the 2 returned, and then it doesn't affect the first 3 elements. So this should resolve that issue now. And there we go. It was accepted. And if we press submit, it will be accepted here as well. And as you can see, 100%, 0 millisecond runtime. The only thing is, this was the exact same runtime as the sorted function up above. It just had a different time and space complexity. Same runtime here. It just depends on the size that you're working with and the complexity. But if we were to look at the space and time complexity of this example as well, we can see that the time complexity is just now O of n plus m. We don't have the additional log of n. And the space complexity is actually going to be O of 1 because we're not creating any new arrays. We're just overriding the initial array. We're not doing the sorted on the new assignment of the variable. We just have 3 pointers here. So it's nothing crazy. We're just going through each of the elements one time, as you can see by O of n plus m. And even if we went through each element twice, you could say 2 times big O of n plus m. But in big O of n, you don't actually use the I don't know what that's called, the number beforehand. You don't multiply it. It's just you remove that constant from it. So in this example, the time complexity would just be big O of n plus m. The space complexity is O of 1, which is also equal to constant space. So there's no change, which is very good whenever we're writing code. So if you have a large data set, instead of having the number of elements in that data set, it'll just be constant space. So now we can see in this example, we did 6 first, then 5, then we went up to the 3, then we returned the 2, and the 1, and we got our final answer. So that's all there is to it. If you have any questions, feel free to write them down in the comments. I'll be sure to answer those. If you have additional things you want to see, if you think that maybe I jumped in a little too fast and you'd prefer to see something a little more simple, breaking down some of these different techniques and tools and functions like sorted and other things like that, feel free to let me know, and I'm happy to explain all of that or go into another video that kind of goes into those a little deeper. But thank you so much again for watching, and I hope that you enjoyed it, and I'll see you in the next one.